Hello there. Today we have another opportunity of learning a very important topic in mathematics, and the topic is approximation. Can you say it with me? Approximation. All right. So we want to learn how to approximate, and this has a lot of clarity as we look at the learning objectives. At the end of the lesson, students should be able to round off numbers, approximate numbers to nearest decimal places, significant figures, and place values. Determine error of approximation and percentage error. Key vocabulary words. Figures. Figures are 1, 2, 3, 4, 5, 6, 7, 8, 9. Digits. Digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. You will notice that there's a difference between figures and digits. And the difference is, you're right, 0. Difference is 0. So figures we have 1 to 9, and digits we have 0 to 9. Place value system. The value of a figure or digits in a decimal number system is what we refer to as a place value system. All right, so if you have a decimal number and you want to look for the place value of a particular figure or digit, then you would then determine the place value, right? So for example, in 543.287, 543.287, 3 is unit. That is, the place value of 3 is unit, and the place value of 4 is tens, and the place value of 5 is 100. Well, after the decimal point, the place value of 2 is tenth, and the place value of 8 is 100th, and the place value of 7 is thousandth. Take note that numbers after the decimal point ends with a th. All right, they end with th. So if it is before the decimal point, you can say it is 10. But if it is after the decimal point, you say it is tenth. If it is before the decimal point, you can say it's 100. But if it is after the decimal point, you say it is 100th. So watch out for those kind of approximation. They can say approximate to the nearest 100th. To the nearest 100 and to the nearest 100th is not the same. All right. So let's watch out for those key vocabulary words. Approximation. It is done by considering the next or immediate number after the required degree, whether it is up to 5 or less than 5. If it is 5 and above, it is rounded up to 1. And if it is less than 5, it is rounded down to 0. Right? This I know you are familiar with. Approximation is an estimated value of the original value and should not be far from the original value. So for instance, 490, when approximated to the nearest 100, should give you something close to 500. All right? But you cannot approximate 490 to 49. That will be absolute incorrect. Okay? You cannot say when 490 is approximated, it should give you 449. So that would be incorrect, right? So approximation should not be far from the original value, even though it is the estimated value. Decimal approximation. This is the approximation that affects the elements. This is the approximation that affects the elements or numbers after the decimal point only. So when you're asked to approximate to the nearest decimal places, you are only considering the number of digits after the decimal point. Watch my word. Number of digits, not number of figure. Number of digits after the decimal point. Zeros included. Okay? So when you're asked to approximate to the nearest decimal places, you watch out for the number of digits after the decimal point. So to approximate to a decimal place, all right, we count the number of elements after the decimal point accordingly and consider the elements immediately after the degree, which we round up or down. What that simply means is that if you are asked to approximate to the nearest decimal, to a particular decimal place or places, you would count the number of decimal places you want to stop and consider only the number immediately after where you are to stop. You will not start approximately from the far end, but only the number immediately after the degree where you have to stop is the only thing you will consider, and then you round up that number or round down the number. For example, 32 points or 32.834 is equal to 32.83 to 2 decimal places. You see that I did not put 0 after the 3, and that's because if you count 2 digits after the decimal point. Since I'm approximating to 2 decimal places, I will only count 2 digits after the decimal point. All right, and in so doing, the number after 3, that is 32.834 to 2 decimal places, means I will stop at 3 and then consider the number immediately after 3. In this case, the number is 4. Since 4 is not up to 5, it will be rounded down to 0. Okay, and therefore my 2 decimal places approximation is 32.83, and that is equal to 32.81 if I approximate to 1 decimal place. All right, so you see that after the 8 there is no any other digits after the 8. Whenever you are approximating to a decimal place, you should only write a number to stop at the according or the required decimal place. Okay, so 32.8 is to 1 decimal place because there is only 1 digit after the decimal point. Significant figure and nearest value. Significant figure, this is a system of approximation where numbers are counted from non-zero elements irrespective of the decimal point. For example, 46.435 is equal to 46.000. In this case, what we are counting is figure. But let me also state clearly that when 0 is between numbers, under approximation of significant figure, the 0 becomes significant. But if the 0 is before the figures or after the figures, it becomes insignificant. So, for this example, 46.435, I want to approximate to 2 significant figures. You see that the first 2 figures there, or the first 2 figures there, is 4 and 6. So I'm to stop at 6. Then the number after 6 is 4, which is not up to 5. So it will be round down to 0. I will not consider the others. Only 4 after the 6 will I consider. And our others will become 0, 0 automatically. So to approximate to 2 significant figure, that will become 46.000 to 2 significant figure. And it will be equal to 46.4, if you like, 00 to 3 significant figure. You can see that in the 3 significant figure, you can count 3 figures there. And those 3 figures are considered significant and important. So to 3 significant figure, it will give you 46.4. Another example, 0.005674 will be equal to 0.006. And that's the 1 significant figure. You see that all the zeros are before the first figure, 5. Okay, so I'm to stop at 5. Fortunately, the digits after 5 is 6. And so I'll round up that 6 because it is more than 5 and add it to the 5 where I am to stop. Okay, so that if I approximate to 1 significant figure, it will therefore give me 0.006. That's the 1 significant figure. Also, if I choose to approximate to 2 significant figure, you see that it will become 0.0057 to two significant figures, because I will stop at the first two figures, which is 5 and 6, and consider only the figure after 6, right, which is 7. And since 7 is more than 5, I'll round it up to 1 and add it to the 6, and that becomes 7. So I will have 0.0057, and that's the two significant figure. Yes, we can do approximation to the nearest value system as well. In this case, this is a system of approximation where the degree is not stated, but with reference to the units of measurement or specification. For instance, the units of measurement can be kilometer. You can say to the nearest kilometer, to the nearest centimeter, to the nearest second, to the nearest hour, and so on. So these are just units, right? But we can also have specifications. This specification refers to place values, right? So we have hundreds, hundreds, tens, tenths, thousand, thousands, and so on. So you can be asked to approximate to the nearest place value. So let's look at an example. Standard form. Okay, before the example, let's look at standard form. This is a system of approximation where numbers is written as a multiple of powers of 10. To write a number in standard form, we move the decimal point to immediately after the first figure and put the number of steps as index on the 10. Note, if the decimal point is moved towards the left, okay, it is going to be a positive index. On the other hand, if the decimal point is moved towards the right, it is a negative index. So for example, 0.00432 in standard form will be equals to 4.32 times 10 raised to power minus 3. 4.32 times 10 raised to power minus 3. Also, 33256 to standard form. Please note that every whole number can be expressed as a decimal number by adding decimal points to the very after the last digit. Okay, so in this case, 33256 is equal to 33256.0, and by the time you want to express as the standard form, you move the decimal point to immediately after the first figure. The first figure in this case is 3. All right, so you move the decimal point. You see, you move the decimal point towards the left, and in how many steps? 1, 2, 3, 4. In 4 steps. All right, so for the decimal point to move after 6 to after 3, or to between the 3's, this decimal point would have moved 4 steps, and because it is moved towards the left, it becomes a positive index 4 on the 10. So therefore, 33256 is now equal to 3.3256 times 10 raised to power 4 in standard form. So let's look at further examples. The situations where you come across this approximation are during evaluation process. Maybe you are computing a value and you have decimal point amongst the value. So you may want to approximate, all right? You may want to estimate. So let's look at an example. Evaluate 0.012 times 0.5 divided by 200, leaving your answer in standard form, one significant figure and 2 decimal places, and then the nearest hundredth. All right, so the best way to do this kind of simplification without calculator is to simply express the numbers in standard form, or in such way that you can easily simplify if you're not to use calculator. All right, so this becomes 0.12 times 0.5 divided by 200 becomes 12 times 10 raised to power minus 3 times 5.0 times 10 raised to power minus 1 divided by 2.0 times 10 raised to power 2. What I have done there is to put all the numbers in a way that I can easily divide and simplify. Okay, and that will be equals to now 12 times 5 times 10 raised to the power minus 3 minus 1, applying indices, over 2 times 10 raised to the power 2. So if I simplify, that will be equals to, 2 can divide 12, and that will give me 6. 6 times 5 is 30. And so this will be 30 times 10 raised to the power minus 4 plus 2. Okay, on simplification, that will give me 30 times 10 raised to the power minus 2, which will be equals to 0.03 in decimal number. Okay, 0.03 as decimal number. And now that we have our answer as 30 times 10 raised to the power minus 2, and we can therefore write it in standard form, because the decimal point ordinarily would be after the 30. So we move the decimal point one step towards the left. And so we add 1 to the minus 2. It will therefore become 3.0 times 10 raised to the power minus 1 in standard form. And that also will be equals to 0.03 to one significant figure, and 0.03 to 2 decimal places, and 0.03 to nearest hundredths. Example: find the product of 0.0019 and 0.015, leaving your answer in standard form. Two significant figure and 1 decimal place. Solution: like I said before, the best thing to do is to express the number in such a way that you can easily simplify. And in such situation, just not like in standard form, but in index form that you can easily multiply. So 0.0019, if I express it in a way that can easily be handled without decimal points, becomes 19 times 10 raised to the power minus 4. Oh, how did I do that? Yes, I moved the decimal point. How many steps towards the right? 1, 2, 3, and 4. Because the decimal point is now after 19. Alright, it becomes invisible anyway, but it's after 19. So because I have moved the decimal point 4 steps towards the right, it will become minus 4 index on the 10. So I have 0.0019 to be equals to 19 times 10 raised to the power minus 4. I'll do the same thing for the 0.015, and that also will give me 15 times 10 raised to the power minus 3. If I combine both, 19 times 15 is 285. Then I apply indices on the 210. I would see that I will have 285 times 10 raised to the power minus 4 minus 3. And that will be equals to 285 times 10 raised to the power minus 7. In standard form, the decimal point is after 285, is after the 5. So I move the decimal point 2 steps to come between 2 and 8. And that becomes 2.8. Because I moved it 2 steps, I will add the 2 steps to the minus 7. So minus 7 plus 2 become minus 5. So 2.85 times 10 raised to the power minus 5 will be in standard form. Then to 2 significant figure, I only want 2 figures in the answer. So if I express it in the normal general form, I will have 0.000285. But because I want to stop at 2 decimal point, I'll stop at 8. That will become 0.000028. But the number immediately after 8 is 5. So I'll round it up to 1 and add it to the 8. So it will become 0.00029. That's to 2 significant figures. And then to 5 decimal places, right? To 5 decimal places, I will have 0.00003 to 5 decimal places. You see that after the decimal point, there are 5 digits. This is a classwork. Please attend the classwork, make a very good approximation of your results according to the required degree, and forward your attempt to my WhatsApp number. If you have any question, I'll be expecting your questions if you have any, and I'll be willing to guide you if you are stuck at any point. All right, and then attempt your assignment and forward your assignments to my WhatsApp number. Okay, forward your your assignment, your attempt of the assignment to my WhatsApp number. I'll be willing to guide, to correct, and to instruct. All right. So I'll see you in our next lesson. Thank you very much for listening.